Let's have a look at operations now with surds. And in particular, we're going to look at addition and subtraction to begin with. The first point is only like surds may be combined using addition or subtraction. So what do we mean by like surds? Okay, so a like surd is where the bases are identical. Okay, so for example, 5 root 6 plus 2 root 6. Well, how many root 6s are there? 5 plus 2 gives you 7. However, root 3 plus root 2 cannot be combined. Okay, so you have to keep it in this form. You can't join them together somehow. But why is this? All right. And the question, I guess, can be answered by looking at some of the fundamental rules of algebra. What's a like term in algebra? I might just write a few here. X squared, x cubed. These three terms are not like terms. The bases are identical, but the powers are not. Right. What about if the powers were identical? Let's say a squared, b squared, c squared. Are they like terms? And again, the answer is no, they're not. Because while the indices are, or the powers are identical, the bases are not. So for a term to be considered a like term, both the base or the bases and the indices have to be identical. So for example, if we had x to the power of half, actually it doesn't matter what the index is. As long as the indices are the same, that's all that matters. So y to the power of half, let's say z to the power of half, and let's say 3x to the power of half. Which ones are your like terms? Your like terms are the terms that have the same pronumeral and also the same power. So we've got that one there and this one there. Okay, so x to the power of half, 3x to the power of half. The pronumerals are identical and the powers are identical. So therefore, they are like terms. Now, you and I know that anything to the power of half is really just a square root, isn't it? So I could basically, rather than writing it as to the power of half, I could write it like this, couldn't I? Okay. So square root of x, okay, and that's 3 root x. Okay. So that is the reason why you can only add and subtract or combine like surds. Okay, so it comes from the laws of algebra. Okay, so in other words, root 3 and root 2. Okay, that's 3 to the power of half. Okay, plus 2 to the power of half. The indices are identical because that's what the square root is represented by. It's represented by the power of half, but the bases are different. This is the base of 3. Base of 2 cannot be combined. Okay, so these are not like terms. All right. So now that we've established that, all right, let's have a look at some examples. Okay. If you like, you can pause the video at any time and give these examples a go, and then obviously play the video and check your solution against the work solution here. All right. First one. 7 root 3 minus 2 root 3. Pretty straightforward. The surds are identical. They're like terms. 7 minus 2, that's equal to 5 lots of root 3. All right. Root 2 plus root 3 minus 3 root 2. Again, like as per the example and as per the explanation in our previous example, in the theory, root 2 and root 3 are not like terms. No, we can't combine those. But root 2 and 3, or negative 3 root 2, can be combined. Okay, so I'm just going to rearrange these terms just so you can see what's going on. What I've done is I've swapped the positive root 3 and the negative 3 root 2 around, and we can now combine the root 2's together. So root 2 minus 3 root 2 is negative 2 root 2 plus root 3, or you could write it as root 3 minus 2 root 2. Okay, it doesn't really matter which way. Okay. All right, what about part C? Root 99 plus root 44. This one on the surface looks like it cannot be combined. Right? They look like unlike terms. However, if we simplify both of these surds, we might be pleasantly surprised that in fact it could be simplified. Let's see. Root 99 That's just 9 times 11, isn't it? So I might just write that, 9 multiplied by 11, plus root 44 is just 4 multiplied by 11. Now, 9 and 4 are square numbers. Okay, they're actually the square factor of 99. Okay, 4 is a square factor of 44. The 9 and the 4 can be taken out of the surd, and it becomes 3 root 11 plus 2 root 11, and that gives us 5 root 11. Alright, hopefully we're satisfied with that. Okay, let's have a look at part D. I just need maybe a little bit of extra space for this one. 3 root 32 minus 2 root 50 plus 8 root 18. Again, on the surface, it looks like these three surds are unlike surds and cannot be combined together. Let's simplify each of these surds. So we've got 32, that's 16 times 2. Okay, so 3. Now, 32 is 16 times 2, square root of 16 is 4, so we can take 4 out, and we end up with a root 2 inside the surd here. I've deliberately skipped a step here, okay? So eventually, once you get good at these, you can basically go straight from 3 root 32 and write it as 3 times 4 root 2, okay? Minus 2 root 50. Well, 50 is a product of 25 and 2. So 50 does have a square factor, the factor 25. Square root of 25 is 5. So that's going to be 2 times 5 root 2, okay? Think about it like this. If you bring the 5 back inside the surd, the 5 becomes 25. Okay, you have to square it when you bring it back inside the surd to sort of undo this the operation of the square root. So 25 times 2 gives you 50. All right, what about the last term, 8 root 18? Well, that's 9 times 2, so there's another square factor in that. If we take the 9 out of the surd, you have to take the square root of that. Okay, so that's going to be 8 times 3 root 2. Okay, we've got square root of 2 everywhere. All right, let's clean this up a little bit. 3 times 4 root 2, that's going to be 12 root 2. Minus 2 times 5 root 2, that's 10 root 2. And then you've got 8 times 3 root 2, that's 24 root 2. All right, so 12 minus 10, okay, is 2. 2 plus 24 is equal to 26. Okay, so that's 26 root 2. All right, hopefully that makes some sense. Let's have a look at, I think there's a few more examples I just want to have a look at before I end this video. Okay, here we go. All right, so there's a couple there that involve some algebra. That doesn't mean that it can't be simplified. Of course it can. Part E, square root of a to the 5 plus 3 root a. Of course, the a to the 5 could be written as a to the 4 times a, couldn't it? All right, so that's just square root of a to the 4, okay, multiplied by a. I'm going to show a little bit more working out here, plus 3 root a. Now, a to the 4, if you bring that outside the surd, it becomes a squared. So this one is really a squared root a. Okay, because think of it as square root of a to the 4. Square root is the power of half, isn't it? So a to the 4 to the power of half is a squared. Okay, then you're left with the root a left over, plus 3 root a. We can factorize out the root a. So in fact, that's square root of a outside of a squared plus 3. Okay, don't be surprised if you end up getting questions like this where there's some factorization involved. Okay, there's no reason why it can't be done. Let's have a look at part F. So square root of x cubed plus the square root of x minus square root of 16x. Again, it's a very similar example to part E. We can take out an x squared from x cubed, can't we? All right, I might just borrow a little bit of space from part E there. So that's just the square root of x squared, okay, multiplied by the square root of x. So that square root of x cubed can be broken up into square root of x times square root of x squared times the square root of x plus the square root of x minus. Now the 16 can come out of the surd, it becomes 4 root x. Now square root of x squared is just x, so that's going to be x root x plus root x minus 4 root x. Okay, can we simplify, combine, factorize perhaps? Yes, of course we can. In fact, we can take out square root of x as a common factor, and you end up with All right, you end up with x plus 1 minus 4. So it's going to be x minus 3. All right. I hope we're happy with that. Okay, if you're not convinced, that's plus 1 here. Plus 1 root x minus 4 root x is negative 3 root x. Okay, and this is x root x here. So taking out the root x as a common factor, you end up with x minus 3. All right, last one. 3 root 363 minus 6 root 243 plus 2 root 192. All right, can we simplify that? Sure can. All right, so 363, you might recognize 363 as triple 121. So 3 root, and I'm going to show a little bit of extra working here, 121 times 3 minus 6 square root of, now 243 looks like triple 81, right? So that's 81 times 3, okay? And what about this one, 192, all right? That one looks like triple 64, I think it is. Yep, it is triple 64. Yep. Okay. Hopefully you can see a bit of a pattern here. So a lot of these numbers that you're given will have square factors in them. That's not guaranteed, but always look for those. Okay. See if you can take out the highest square factor. Okay. 192. Okay. 192. You could take out 4 as a factor. That would work, but it won't give you the simplest surd, right? So you got to try and take out the highest, the highest square factor that you can find. Okay, well, generally speaking, that's the best way. Okay, now root 121, that's just 11, isn't it? So that's just 3 times 11 times root 3 minus 6 times root 81 is 9 times root 3 plus 2 times root 64, or square root of 64, is 8 times square root of 3. 3 times 11, 33 root 3, minus 54 root 3, plus 16 root 3, and quickly just adding those up, right, we get negative 5 root 3 as our simplified answer.